Hello, can you hear us?
Wait.
Are you sure you don't want to?
What?
Are you sure you don't want to open it?
Gloria 你講先，你温靜講先㗎。
Screen sharing so I can stop screen sharing.
Matthew 你係咪食緊嘢啊 ？Matthew，我 take the time。
寫晒 script 背晒，跟住一個人都冇。
聽到你。
而家揼我哋去。
Hi.
Hi, how you doing?
Hello.
Good. I'm still waiting for some of my students. Is it all right if you can give us 5 more minutes?
Oh, yeah, that's no problem at all.
Okay, thank you. Không sao không ạ? Thank you for that. À, 好啊，好啊，好啊。Alright, the camera is here, okay? Screen is here. 咁你望係望個 camera， 唔係望個 screen， right？ 睇唔到啊！
我而家
未唔齊啊嘛，唔夠温陣啊嘛。係點啊？夠唔夠電啊？係啊，而家要
我哋以前係用嗰個好大嘅，
即係出到下面呢度。呢個係讀 OPEC， 係咪 OPEC？ Saudi Arabia。
呢個問題我知啊。
喂 ，WhatsApp 啊 ，Vincent 叫快少少㗎。
我打緊電話俾佢啦，但係封咗門。我俾佢打俾其他人。
係啊係啊，嗰啲開始。
封咗門聽咯。我係嘅話，我點嘅？冇俾佢，冇俾佢俾幾多佢？點俾佢？係啊，同意啊。你哋3個點俾佢？直接落呢條。
OK。
呢陣聽我同佢冇分別，大家都三個鐘啊。呢陣通咗我聽。你都叫做係用咗邊陣打過啊？如果跟住係咪應該
Ricky 咧？打埋俾 Ricky。
呢度有冇我諗呢個？我哋Ricky 去打 ，Ricky 有打，我打 Ricky，係咪 Ricky 啊，我估 Ricky 應該屬於神。係佢見到佢，已經即係都有咁講嘅。你叫我聽翻嚟落啲乜咧？
你有冇問啊？係石神記。
西咧？西你打俾阿西啦，打俾阿西啦。阿西應該聽電話話西，喂，聽咯。我都係咁。
係啊，我頭先301咁樣升下升咗個 script，
聽咗啊！
即係我哋最近個 printer 係有個 script
應該用咩有嗰個但係真係請啦，邊個嚟㗎？我打咗俾佢啊！我諗下嘥，有啲凍咯。咁你全部聽到曬啦，跟住。
我哋好似未瞓醒。
唔係，我覺得呢個一定係有嘅事，呢個唔使講嘢嘅。阿婆咁咯，阿婆喂，呢個喺邊啊？阿婆係啊，阿婆呢邊講緊。點解？因為佢你都講條喺度冇錯。同呢個 friend 係嘛？你接到呢個 friend？
我真係俾點 learn 嘅喎。
呢個都 OK。好啊，贊成。
呢啲人應該有
食咗嘢啦。
係啦。
嗰陣行啦，點啊？你琴日唔係講話呀？我琴日話啦，我打晒佢啦，我全部打。你打咩？你打咗佢。唔通？因為我已經翻咗啦。我咩意思啊？你啊，你嚟啊！對群死啦！媽個，我之前呢個是乜？有啲人我就玩後卡行喺邊啊？你邊度去啊？你喺邊啊？快啲啦！我哋要準備開始。你台嗰地睇啦。喂，好意思啊！快啲啊！你邊度啊？我覺得你似講笑啊！唔係認真地邊度啊？快睇啊！呢個冇知啊！啱先我話前5分鐘第一個喎。前5分鐘一個點樣？前5分鐘一個點樣啊？係啊！認真啊！係你自己睇啦。喂，全部人都到晒單入去。你今日好多錢？得，好啦，拜拜。你頭先你嗰個你唔講咩？你頭先
喺邊啊？
佢喺學校嘅邊實同一寫下面上。
可能話你係成日。呢個你嗰邊有教書。喂，跟住第二篇咧。第二篇個花粉咯。喺下面啊。都係呢個 WhatsApp 邊。你頭先邊個話翻嚟？我講。唔係佢啊。放呢個位咧，即係都可以坐點咩咯？其實都唔理佢啦呢個。其實談風衰嘅事。一定答佢。
Were y'all ready to begin yet?
Are we just waiting for 2 more students? Then we can start.
All right, thank you.
Hello? Hello, can you hear me?
Yes, we can hear you fine.
Hello.
Hi, we are ready to start. I have two speakers, Gloria and Winston. Can we
Good.
start? Yeah?
Yes.
All right. Winston, 開始啦。介紹自己啊，OK。見唔見到佢啊？
So I was speaking first.
Yeah, ask you, did you want us to speak first or did you want to speak first?
Did you want us to speak first?
Yes, please.
Okay, go ahead.
Okay, well, just introduce ourselves.
I'm Alondra Montezuma.
And I'm Jacob Shaw. I'll be the second speaker, and my partner, Alondra, will be the first speaker. And she'll begin if you're ready.
開始啦，人哋介紹咗自己咧，唔好反應咗，你哋識唔識聽英文㗎？
Are you ready for her to begin?
I'm Gloria from Year 11.
You're introducing us.
開始啦。Screen 咧，揾唔到 screen。俾佢。
Good morning, respected educators, our honorable opponent and member of audience. I'm Vincent from Year 11 of Polanco Ross Foundation College. Our team is going to speak for the topic. We are running out of oil and oil is a fossil fuel. According to Oxford Dictionary, fossil fuel means a natural fuel such as coal or gas, formed in a geological past from the remains of living organisms. With the increase in global population demand for energy, such as oil, it's also rocket. As demand of oil cannot catch the production, we are running out of oil. Formally, our team line agreed that oil is a fossil fuel, and we are running out of oil. The reason why oil is being agreed to be a kind of fossil fuel is also called petroleum, which is found way down in the ground, usually between layers of rock. To get oil out, or while it's dark, fossil fuels are now renewable energy sources that formed more than 300 million years ago during the Carboniferous period. Long before dinosaurs roamed the earth, fossil fuels are made up of plant and animal matter. When plants or animals died, their bodies decomposed and were buried under layers of earth. Millions of years later, oil is formed. Are we running out of fossil fuels? Our answer is yes, according to the International Energy Agency. In 2014, our supply of oil is 30.5 million of barrels per day. However, our demand of oil is nearly 94 million of barrels per day. It proves that we are running out of oil. Because oil is a fossil fuel, and we are running out of oil, many countries, such as European Union, Hong Kong, Japan, are promoting renewable energy, so that countries could reduce the amount of oil used. The implementation reflects that the world is going to be running out of oil, as oil is the main supply of energy generation. However, can oil be replaced? Do we have any substitute? Currently, no. The global energy sector is by far the world's biggest industry, with more than 5 trillion per year spent refining and delivering energy of various forms to consumers. Renewable sources like wind and solar have their virtues, but they cannot compare with oil when it comes to economics. Recently, there is an analysis by the Energy Information Administration estimates that wind-generated electricity from onshore wind turbines costs 97 per megawatt hour. That's about 50% more than the same amount of electricity generated by oil, which the EIA estimates costs 63. Offshore wind is even more expensive, coming in at 243 per megawatt hour, the least expensive form of solar-generated electricity. The type generated by photovoltaic panels costs 210, or more than 3 times as much as the juice produced by using oil. If renewable sources of energy were dramatically cheaper than
hydrocarbons, then perhaps we could be more optimistic about their ability to capture a larger part of the global energy mix. And even if they are true, a wholesale change in our energy mix will take a longer time. Nothing else comes close to oil when it comes to energy density, ease of handling, flexibility, convenience, cost, scale. Modern batteries are only slightly better than the ones that Thomas Edison developed. But gasoline has 80 times the energy density of the best lithium-ion batteries. Let me use e-cars as an example. E-cars using electricity as energy source. However, electric cars are limited by range and speed. Most of these cars have range about 50 to 100 miles and need to be recharged again. You just can't use them for long journeys as of now, although it is expected to improve in the future.
In addition to the mentioning measures, our team does not agree that oil companies are manipulating the oil production, thus leading to insufficient oil supply and the supervision of OPEC. Due to the fact that the price and the production of oil depends on the status of purchase, demand, and supply, as well as the socio-political factor of the origin of fossil fuels. According to USA Today in 2008, high oil prices were driven by a decline in dollar, as most oil contracts around the world are traded in dollars. As a result, all exporting countries usually peg their currency to the dollar. When the dollar declines, so do their oil revenues, but their costs go up, which shows a negative relationship. Therefore, OPEC, Organization of the Petroleum Exporting Countries, must raise the price of oil to maintain its profit margins and keep costs of imported goods constant. Therefore, the oil companies are only adjusting the price of the oil by different factors, mainly the lack of oil supply. With reference to the demand-supply balance until the first quarter of 2015, from the first quarter of 2009, the demand of oil is generally increasing and fluctuating from 84 to 19 million barrels, and surplus is shown in 2015, in which the supply of oil is much more than the demand of oil. However, OPEC doesn't want oil prices too high or alternative fuel sources to look good. OPEC has set its target price for oil is between 70 to 80 a barrel. In 2008, Saudi Arabia announced it would increase supply. This was one reason prices started to drop. Oil price from the beginning of the 20th century up to the 1990s has been affected mainly by wars and conflicts, while the last 3 decades show that price fluctuations have been the result of global financial markets and increasing economic integration around the world, such as World War and Great Depression and Gulf War. In recent history, the first significant event that affected oil price was World War I, when the price more than doubled between 1940 and 1980, from 81 cents to $1.98 per barrel due to supply cuts and high oil demands in the World War effort. According to West Texas Intermediate, in the aftermath of the Great Depression in 1929, prices fell from $1.27 per barrel to 97 cents in 1935. During World War II, prices rose from $1.02 per barrel in 1939 to $1.21 per barrel in 1944, and increased to $1.99 per barrel in 1948 with post-war construction and the Industrial War. This war showed that the oil price increase due to wars but not the manipulation by oil market, as well as when there is financial crisis, the oil price will go down. Moreover, OPEC, which its mandate is to coordinate and unify the petroleum policies of its members and to ensure the stabilization of oil market in order to secure an efficient, economic and regular supply of petroleum to consumers, a steady income to producer, and a fair return on capital for those investing in the petroleum industry. So oil companies cannot manipulate the oil market due to the supervision of OPEC. Although renewable energy can be used for generating energy, it is difficult to generate the quantities of electricity that are as those produced by traditional fossil fuel generators. Also, renewable energy often relies on weather for a source of power. For example, hydro generators need rain to fill dams to supply flowing water. Solar collectors need clear skies and sunshine to collect heat and make electricity. When these resources are unavailable, so is the capacity to make energy from them. This can be unpredictable and inconsistent. The current cost of renewable energy technology is also far in excess of traditional fossil fuel generation because it is a new technology and as such has extremely high capital costs. So the supply of oil cannot be changed easily as renewable energy cannot help to replace fossil fuel. Oil has taken between 50 to 300 million years to form, and yet we have managed to burn roughly half of all global oil reserves in merely 125 years or so. The world now consumes 85 million barrels of oil per day, and demand is growing exponentially. Oil production in 33 out of 48 countries has now peaked, include Russia and Mexico. Global oil production is also approaching an all-time peak and can potentially end our industrial civilization. The most distinguished and prominent geologists, oil industry experts, energy analysts, and organizations all agree that the big trouble is brewing. It is now widely acknowledged by the world's leading petroleum geologists that more than 95% of all recoverable oil has now been found. We therefore know, within a reasonable degree of certainty, the total amount of oil available to us. Any oil well has roughly the same life cycle where the production rate peaks before it goes into terminal decline. This happened when half of the oil has been recovered from the world. We have consumed approximately half of the world's total reserves of about 2.5 trillion barrels of conventional oil in the ground when we start drilling the first well at a current rate of over 30 billion a year, meaning the world is nearing its production plateau. Oil is now being consumed 4 times faster than is being discovered, and the situation is become critical. So oil is really running out but not manipulated by oil companies. Our team sincerely feels that the oil companies are not manipulating, and oil is a fossil fuel which is going to be running out. Thank you.
Thank you. We will now begin with our speeches. My partner will be speaking first.
Okay. So I'll do the first speech. Oh, can you hear me?
Yes, we can.
Okay. Thank you. May I please court your honor? I, Alondra Moctezuma, and my partner Jacob Shaw will represent the petitioner, the people in this case. Today the question is a very simple one. Is oil a finite resource? I will speak on the first point of error, how oil is created. This is a fundamental aspect of this entire case. We will prove what oil actually is, how it's created, and what is happening in oil markets today. To do so, we pose a question. Why does everyone seem to believe in the Herc's peak oil theory? Why does the public believe in this theory? Within our arguments, I present convincing evidence that the peak oil theory is based on false premise. The oil is a finite resource, and I will show how oil is actually created. Certified Hoyle in 1982 commented, the suggestion that petroleum might have arisen from some transformation of squawfish or biological detritus is surely the slightest notion to have been entertained by a substantial number of people over an extended period of time. Certified Hoyle, FRS 1982. Charlie E. Melton and A.A.A. Gardini in 1983 explained the general concept of petroleum formation by a biogenic mechanism has been firmly entrenched for a long period of time. There has been no accumulation of convincing experimental evidence in support of this belief. Currently, the publicly held theory is that oil and gas are both driven through the nature and lengthy decomposition of organic detritus. Therefore, people who naturally believe that oil is a finite resource and that it would eventually run out. In this courtroom today, we will show you that oil and gas are continuously formed and replaced from a purely physical and chemical thermodynamic process, continually regenerates oil from ultra-deep location 19,000 meters. The inference here is that oil may perhaps not be a finite resource and that there is plenty of it. First, oil and gas origenic. Biogenic or abiotic. Do oils and gas originate from a biological decomposition of organic material, or do they originate simply through the nature and physical and chemical thermodynamic process involving heat and pressure? And it is notable that the whole of Herc's theory of peak oil rests completely on the assumption that oil is biogenic in origin. Therefore, oil is a finite resource. Simply everyone believes this because everyone believes that this is a proven fact. I have also read that biogenic theory directly contradicts and offends the second law of thermodynamics. Evidence for the Western biogenic theory of oil formation. First, in 1757, Russian scientist Milaho Lomonosov put forward a hypothesis suggesting that oil came from a biological detritus. This was based upon the theory was first introduced by George Agricola in 1556. George based his work on Greek Aristotle's work in 1757. Applying little more observation and limited analytical tools available in this time, Russian scholar Milaho V. Lomonosov is strongly considered to have been farther than the theory that crude oil, after percolating for a great duration of time, might originate from a biological material. The notion that oil is a fossil fuel was first proposed by Russian scholar Milaho Lomonosov in 1757. Lomonosov's rudimentary hypothesis based on the limited base of scientific knowledge that existed at the time, and on his own simple observation was that rock oil originates as tiny bodies of animals buried in sediments, which under the influence of increased temperature and pressure acting during an unimaginable long period of time transformed into rock and oil. 2.5 centuries later, Lomonosov's theory remains as it was in 1757, an unimproved, almost entirely speculative hypothesis. Returning once to the Wall Street Journal, we find that although the world had been drilling for oil for generations, little is known about the nature and resource of the underground activities that it led to its creation. In spite of the great amount of scientific research, there are many unresolved questions regarding its origin. Doesn't that seem a little bit odd when we're talking here, after all, about a resource that by all accounts plays a critical role on the vast area of human endeavors? By one published account, petroleum is a raw ingredient in some 70,000 manufactured products, including medicine, synthetic fabric, fertilizers, paint, varnish, acrylic, plastics, and cosmetics. By many accounts, the very survival of the human race is entirely dependent on the ability of petroleum, and yet we know almost nothing about this most life-sustaining of the Earth's resource. And even though by shrill accounts, the well is about to run dry, no one seems to be overly concerned with the understanding of the nature and origins of the so-called fossil fuels. We are rather content with continuing to embrace an unapproval of the 18th century theory that is subjected to any logical analysis seems ludicrous. As anyone who stayed awake and during high school science class knows, oil comes from dinosaurs. I remember as a student hearing my teacher go over and over on the fact that oil was a fossil fuel and we were running out of it. It seemed a reasonable idea at the time from a perspective of a 16-year-old, but as an adult, you really stop to give it some thought. Doesn't that seem a little, what's the word I'm looking for here? Oh yeah, I remember now. There it is. How could dinosaurs have possibly created the planet's vast oil fields? Did millions or even trillions of them die at the very same time and at the very same place? Were the dinosaurs Jonestown on a great scale occurring at a location all across the planet? And how did they all get buried so quickly? Because if they weren't buried right away, wouldn't they just have decomposed and been consumed by scavengers? And how much oil can you really squeeze from a pile of parched dinosaur skeletons? How much dead dinosaurs does it take to make a barrel of oil? How many barrels of oil have we used so far? If dinosaurs caused the oil, or more correctly, their dead bodies decaying caused the oil, that shouldn't it be a simple formula to figure out how many dinosaurs it took to make oil? Isn't the scientist in reverse? If oil were fossil fuels, could you not figure out one simple fact? And also, wouldn't that make all oil the same age? Wait, if all oil were the same age, that would mean that the dinosaurs that made all the oil all died at the same time, correct? Maybe there was some type of catalytic event that caused the sudden extinction of dinosaurs all buried them, like the impact of an asteroid or a comet. Even so, you wouldn't think that all dinosaurs would have been just huddled together waiting to become oil fields. And besides, scientists are now backing away from the mass extinction theory. Does this mean without mass extinction, you cannot have oil as a fossil fuel? Does it also mean that since oil we have all today was all made at one time, that oil had to come from some sort of sudden extinction? If dinosaurs lived for millions of years before, what did their dead bodies produce? Therefore, it would take a pretty big pile of dinosaurs to account for the estimate of 660 billion barrels of oil in the Middle East. I don't know what the percentage dinosaur carcass to the barrel of oil conversion rate is, but it does seem like it would take a hell lot of dinosaurs. Even if we generally allow a single dinosaur to yield 5 barrels of oil, more than 130 billion dinosaurs would have been entombed in just one small region of the world. But were there really hundreds and billions of dinosaurs roaming the earth? If so, then one wonders why there's all these talks about now overpopulation and scarce resource, when all we are currently dealing with is a few millions of humans populating the same earth. Could the earth had 130 billion dinosaurs in one place like in the Middle East? Now, you would have to multiply that with the United States, Mexico, Venezuela, Russia, Nigeria, and all other leading oil-producing areas of the world. Quickly, you will see that we would have had over 1 trillion dinosaurs on the earth, all dying at one time. We have found some fossils, but not in some type of scale. The answer is frowning, no. And why the Middle East? Was that some kind of mecca for the dinosaurs? Was it its climate or the lack of water and vegetation that drew them there? Of course, the region had been much different in prehistoric times. Maybe if it was like in the Middle East to get a Great Valle, but they never made it because they just dug down in desert, automatically became cans of 10W motor oil. Another version of the fossil fuel story holds in the microscopic animal carcass and other biological matter gathered on the world's seafloors, with organic matter being covered over with sediment over the course of millions of years. You would think, however, that biological matter would decompose long before being covered with sediment, but I guess not. And I guess that there's no bottom feeders in those days in the ocean floors for organic debris. Fair enough, but I still don't understand how the massive piles of biological debris will consist of 100 and billions of tons of matter could have just suddenly appeared, so that they can just sit there undisturbed for millions of years and they were covered over with sediment. I can't understand how biological debris could accumulate over time mixed with sediment, but that wouldn't really create the condition for the generation of vast reservoirs of crude oil, so I'm guessing I might be missing something here. This theory makes some sense, correct? How we found that most cases, the places that have been produced oil in the past, West Texas and Middle East, for example, were old seabeds. So maybe this theory is correct. It wasn't that the dinosaurs entirely, it was all plants and animals in the ocean that died. This This makes perfect sense until you begin to apply some questions. Did all the plants and animals in the ocean die at once? How can you have oil created from the surface of the earth downward, and the oil at the top the same age as the bottom? You can't. According to their own theory, the oil had to be made all at once. For example, let's look at a cook preparing a large kettle of a homemade soup. He puts the stock in the kettle, heats the kettle slowly, and then adds different parts of the soup. As the soup is cooking, he continues to add ingredients. He adds ingredients until the exact time the soup is served. Would all the ingredients be cooked? Would all the ingredients be done? The answer is, of course, no. I realize that this is a soup and it's not oil, but the analogy is very much the same. You must question the fact that, biologically speaking, for oil to be biotic, it would have to have a single source or cause and would have to be cooked from the bottom up, not the top down. This means clearly that oil is a fossil fuel. Fossils will have to be found at the base of the deposit of the oil. This means fossils will be found at levels deeper than oil is currently being pumped at. Today, Russia has had many oil wells that were over 30,000 feet deep, yet the deepest fossil fuel has been found is 16,000 feet below the surface of the earth. In conclusion, let's compare the two theories and how oil was created, see which one makes more sense. In Leung's theory in 1757, you either have trillions of dinosaurs dying at the same time and plants/dinosaurs in the ocean dying. After they die, they all decay at the same time and recreate oil. Cross-apply these factors. First, for oil to be a fossil fuel, we have to be overly populated with dinosaurs. Second, they all have to die at the same time. Third, oil on top of the oil field would have to be newer than oil at the bottom of the field. Fourth, fossils would have to be found at the bottom of all areas that have been drilled. The interesting fact is none of this happened. Bones of dinosaurs have not been found in numbers sufficient to justify point 1. No scientific evidence has been shown to cause point number 2. The age oil in field doesn't differ, and fossils have been found only 16,000 feet, even though they are producing wells that have been dug over twice as deep. Whereas the abiotic petroleum hypothesis first gained significant exposure outside the Soviet Union during the 1977 gasoline crisis, when Cornell astrophysics Thomas Gold published an editorial in Wall Street Journal in which he claimed was the most hydrocarbons was generally abiotically in the mantle and migrated to the crust, where they acted as an energy source for microbes, producing a deep microbial ecosystem, the deep hot biosphere. That may rival the surface of biosphere in the mass and volume. The organic remains of microbes in the deep hot biosphere represents the source of biologically molecules in petroleum as biological overprint onto an abiogenic organic mixture. The proposal contains an implicit concession that the biological molecules in petroleum cannot be generated by a polymerization of methane. Echoing some of the previous arguments of Russian-Ukrainian school, Gold represents several lines of evidence in abiotic petroleum, including first, the presence of clearly abiotic hydrocarbon and other organic molecules in meteorites and on other solar system bodies. Second, plausible synthetic pathways for mantle hydrocarbon production. Third, the association of hydrocarbon decomposition with helium and other trace gases, presumably with mantle sources. Fourth, the existence of an extensive deep microbial community that impact and overprint of biomarkers onto an abiotic petroleum. Fifth, the tendency of hydrocarbon reservoirs to occur at many depths in a single locally implying an underlying depth source. Sixth, the distribution of hydrocarbon deposits related to underlying mantle structure. 7, the distribution of metals and other trace elements in petroleum which correlate more strongly with chondrite composition with presumed crucial source. And 8, the occurrence of hydrocarbon in non-sedimentary formations such as crystalline rock. Clearly, looking at both the abiotic and biotic theory of the creation of oil, we can see which one is scientific and which one is not based on facts. If there are no further questions, I will retire and allow my partner Jacob Shaw to present the second point of error. We pray that you vote for the petitioner in this case.
In the streets,
Yeah.
May it please the court, Your Honor, I, Jacob Shaw, will now speak on the second point of error. If we know that oil is not biotic in composition and is therefore not finite, why are we still believing in the biotic formation of oil? Please cross-apply all my partner's points, and I'd like to begin with a brief review of how to get into this discussion. The history of petroleum science had begun in 1757 when a Russian person of natural gifts, M. Lomonosov, suggested the hypothesis that oil might originate from biological detritus. During the end of the 19th century, famous Russian chemist Dmitry Mendeleev declared that oil was a primordial native material from great depth, mantle. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not new or recent. This theory was first enunciated by Professor Nikolai Kurdetsev in 1951, almost half a century ago, and has gone extensive development, refinement, and application since its introduction. There have been more than 4,000 articles published in the Soviet scientific journals and many books dealing with the modern theory. The writer is presently co-authoring a book upon the subject of the development and application of the modern theory of petroleum, for its bibliography requires more than 30 pages. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not the work of any one single man nor of a few men. The modern theory was developed by hundreds of scientists in the now former USSR, including many of the finest geologists, geophysicists, geochemists, and thermodynamicists of that country. There have now been more than 2 generations of geologists, geophysicists, chemists, and other scientists in the USSR who have worked upon and contributed to the development of the modern theory. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not untested or speculative. On the contrary, the modern theory was severely challenged by many traditionally minded geologists at the time of its introduction. And during the first decade thereafter, the modern theory was thoroughly examined, extensively reviewed, powerfully debated, and rigorously tested. Every year following 1951, there were important scientific conferences organized in the USSR to debate and evaluate the modern theory, its development, and its predictions. The all-union conferences of petroleum and petroleum geology in the years of 1952 to 65 deal particularly with this subject. During the period, when the modern theory was being subject to extensive critical challenge and testing, a number of the men pointed out that there had never been any similar critical review or testing against the traditional hypothesis, that petroleum might somehow have evolved from spontaneously biological detritus. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not a vague qualitative hypothesis, but since it's a rigorous analytic theory within the mainstream of the modern sciences. In this respect, the modern theory differs fundamentally not only from the previous hypothesis of a biological origin of petroleum, but also from all traditional geological hypotheses. Since the 19th century, knowledgeable physicists, chemists, thermodynamicists, and chemical engineers have regarded with great reservations, if not outright disdain, the suggestion that highly reduced hydrocarbon molecules of high free enthalpy, the constituents of crude oil, might somehow evolve spontaneously from highly oxidized biogenic molecules of low free enthalpy. Beginning in 1964, Soviet scientists carried out extensive theoretical statistical thermodynamic analysis, which established explicitly that the hypothesis of evolution of hydrocarbon molecules, except methane, from biogenic ones in the temperature and pressure regimes of the Earth's near surface crust was glaringly in violation of the second law of thermodynamics. They also determined that the evolution of reduced hydrocarbon molecules requires pressures and magnitudes and current depths equal to such the mantle of the Earth. During the second phase of its development, the modern theory of petroleum was entirely recast from a qualitative argument based upon the synthesis of many qualitative facts into a quantitative argument based upon the analytical arguments of quantum physical mechanics and thermodynamic stability theory. With the transformation of the modern theory from a synthetic geology theory argued by persuasion into an analytical physical theory argued by compulsion, petroleum geology entered the mainstream of modern science. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not controversial nor presently a matter of academic debate. The period of debate about this extensive body of knowledge has been over for approximately 2 decades. The modern theory is presently applied extensively throughout the former USSR as a guided perspective for petroleum exploration and development projects. There are presently more than 8 oil and gas fields in the Caspian district alone, which were explored and developed by applying the perspective of the modern theory and which produced from the crystalline basement rock. Similarly, such exploration to the Western Siberia Cratonic sedimentary basin has developed 90 petroleum fields, of which 80 produce either partly or entirely from the crystalline basement. The exploration discoveries of the 11 major and 1 giant fields in the northern flank of the Dnipro-Donetsk basins have already been noted. There are presently deep drilling exploration projects underway at Zbran, Tatarstan, and in Siberia, directed to testing potential oil and gas reservoirs in the crystalline basement. It appears that, unbeknownst to Westerners, there have actually been, for quite some time now, 2 competing theories concerning the origins of petroleum. One theory claims that oil is an organic fossil fuel deposited in finite quantities near the planet's surface. The other theory claims that oil is continuously generated by natural processes in the Earth's magma. One theory is backed by massive body research representing 50 years of intense scientific inquiry. The other theory is an unproven relic of the 18th century. One theory anticipates deep oil reserves, refillable oil fields, migratory oil systems, deep sources of generation, and spontaneous venting of gas and oil. The other theory has a difficult time explaining any such documented phenomena. So which theory have we in the West, in our infinite wisdom, chosen to embrace? Why? The fundamentally absurd fossil fuel theory, of course, the same theory the peak oil doomsday warnings are based upon. I'm sorry to report here, by the way, and doing my homework, I never did come across any of that hard science documenting peak oil that Mr. Straw referred to. All the peak oil literature that I found on Rupert's site and elsewhere took for granted that petroleum was a non-renewable fossil fuel. That theory is never questioned, nor is any effort made to validate it. It is simply taken to be an established scientific fact, which it quite obviously is not. First, look at the abiotic hydrocarbons in space. Carbon is the fourth most abundant element in the cosmos, and remote observations indicate the universe is replete with organic compounds produced without the influence of biology. Studies of absorption spectra of dense molecular clouds reveal more than 150 small molecules. The greatest amounts of hydrocarbons in our solar system are associated with the gas giant planets and their satellites, where significant amounts are present in atmospheres and on icy surfaces. The prevalence of non-biological hydrocarbons in the early stages of our solar system is evidenced by the chemistry of carbonaceous meteorites, which represent fragments of ancient asteroids unchanged since shortly after the birth of the solar system. Carbonaceous meteorites contain percentage levels of organic matter that were generated in the absence of biology. The widespread presence of organic matter in the cosmos suggests that no exotic mechanism, therefore, need be invoked to propose abiogenic hydrocarbons on Earth. In fact, the biogenic origin of some hydrocarbons on Earth is, thus far, a unique observation in an abiotic hydrocarbon-rich universe. In contrast to our cosmic environment, organic matter on Earth is associated primarily with biological processes. The distinction between biological and non-biological organic matter has held a long-term fascination for scientists and philosophers. For instance, all ancient mythologies invoke divine intervention and use some abstract vital force for the production of organic compounds that constitute life. Following the 7th to 6th centuries BC, such vitalist theories were often challenged by more materialistic concepts that assumed only differences in levels of organization between living and non-living entities. A key moment for materialism came in 1828 when Friedrich Wöhler produced organic chemical urea for inorganic ammonium cyanate, using a procedure now called the Wöhler synthesis. The generation of organic compound from inorganic material affects the ability of non-biological processes to produce organic materials, and is an inevitable conclusion that the origin of life on Earth is by definition a process of abiotic organic synthesis. In general, organic compounds generated by abiotic reactions, such as those produced by meteoritic organic matter, are characterized by complete structural diversity. Biological organic compounds produced by synthetic reactions directed by enzymes are notably specific in structure. Organic compounds, petroleum, by contrast, contain numerous structures and abundances that cannot be produced by the random polymerization from methane. Second, experimental hydrocarbon synthesis. Hydrocarbon synthesis is achievable under laboratory conditions and in shallow geological environments, and several key reactions are notable. First, the Fischer synthesis involves the conversion of carbon monoxide or carbon dioxide to hydrocarbons. The products of Fischer synthesis are low molecular weight hydrocarbons and have the form of Sussware distribution, where the log of the hydrocarbon concentration decreases linearly with increasing carbon numbers. The Fischer process has been proposed as a generator of hydrocarbons in hydrothermal vent settings. Second, simple thermal metamorphism of carbonates such as calcite, dolomite, and siderite at 400 degrees Celsius and the presence of hydrogen gas can produce low molecular weight hydrocarbons. Third, total metamorphism of carbonates and graphite below 400 degrees Celsius may generate methane. Fourth, methane is common in mid-ocean ridges and serpentinization reactions are implicated. Hydrogen forms during dehydration of olivine and can combine with carbon dioxide to form methane. In addition, for those reactions that proceed under conditions relevant to the Earth's inner surface, the influence of pressure may be an important factor for synthesis. This environmental control is especially pertinent to the theories of deep gas and a number of experimental studies at elevated temperatures and pressures relevant to deep crust and magnetic conditions, point to the possibility of deep abiotic hydrocarbon synthesis. First, the generation of petroleum hydrocarbons up to C10H22 was demonstrated using solid iron oxide, marble, and water temperatures of 1500 degrees Celsius and pressures above 3 gigapascals, corresponding to a depth of more than 100 kilometers. Second, a heated diamond anvil cell had been employed to explore the calcite iron oxide water system at mental pressure and temperatures. Based on Raymond's spectroscopic and X-ray diffraction evidence, methane and possibly other light hydrocarbon species were successfully synthesized. Experiments represent the first attempts to test the Russian Ukrainian school hypothesis under conditions comparable to those found in the mantle. Subsequent experimentation has successfully repeated the observations. Third, pressures above 2 gigapascals and temperatures from 1000 to 1500 Kelvin appear to induce polymerization from methane to hydrocarbons, molecular hydrogen and graphite. The reactions are reversible under these conditions. Although elegant and efficient reactions exist that can produce substantial amounts of hydrocarbons from simple precursors in apps biology, care must be taken when extrapolating data to natural settings. Convincing evidence must be found that the production mechanism is contributing. Lessons can be learned from meteoric organic matter studies, where the attractive Fischer-Tropsch mechanism has supported even though ample evidence was available and its reaction was not contributing quantitatively significant amounts of material to the organic inventory. Third, hydrocarbons in minerals. Evidence has been presented from organic molecule assembly and igneous rocks. According to Fruin's hypothesis, igneous metals inevitably incorporate carbon and other impurities at high temperatures. As minerals crystallize, they also incorporate a small amount of carbon, which concentrates on linear crystal defects and form alkanes. However, these results have been challenged by other workers. Fourth, abiotic hydrocarbons form hydrothermal vents. A number of authors have presented experimental, theoretical, and field evidence for the possible release of abiotic hydrocarbon species from hydrothermal vents. Hydrocarbons have been collected from numerous field sites. Observations of gas chemistry, abundance, and flux in various vent settings have provided an opportunity to assess quantitatively the relevance of proposed abiotic species to commercial oil and gas resources. Mean values of molar CH43 helium and matter-derived fluids imply less than 200 ppm of abiotic gas are present in economic relevant reservoirs. These field observations of hydrocarbons from hydrothermal systems have been complemented by experimental studies that attempt to replicate natural conditions. A number of these experiments have demonstrated abiotic formation of methane and other organic compounds, particularly in studies that mimic serpentinization. The experiments underscore the importance of traditional elements and the hydrothermal synthesis of organic molecules by Fischer-Tropsch reactions. These results suggest an intriguing connection between mineral-mediated organic synthesis and biological catalysts, many of which incorporate traditional metal atoms and their active sites. Biochemical reactions run by enzymes that incorporate traditional metal atoms may thus represent reaction pathways that have survived and evolved from the prebiotic geochemical world. Crossed by the main argument put forward by Western biotic oil theorists is that biomakers are always found to exist organic detritus within all oil deposits, which is certainly true. But unfortunately, oil exists inside the earth and surrounded by different types of geological soils, which all contain organic detritus. And oil is a wonderful solvent in which to dissolve and hold the detritus. Also, and by the reverse argument, alkanes, carriages, and many other petroleum-related chemicals have been found on meteorites, which can support no organic life. Caused by the fact that no fossils have been found below 16,000 feet, and oil is being currently drilled up to 40,000 feet, we're left with a controversy. Why are we not told the truth? 7 reasons why we're not told the truth about the forces of oil. First, in this paper, the abiotic oil controversy by Richard Heimberg, which sides with biogenic oil with relatively little actual coded research evidence, has even admitted there is no way to conclusively prove that no petroleum is of abiotic origin. Perhaps one day there will be general agreement that at least some oil is indeed abiotic. Maybe there are indeed deep methane belts 20 miles below the Earth's near surface. But an important question to keep in mind is, what are the practical consequences of this discussion now for petroleum and global oil depletion? Classify the facts. You can't prove that it isn't. Classify some maybe. Although by doing this, biotic oil theories are actually turned on their own theory. Classify the real problem here for biotic oil theories is not how oil is created, but it is running out. This is a logical fallacy. The creation of a false dilemma. How can you run out of a product that is unlimited? Second, American geologist Kingham and Hubbard predicted in 1956 that peak oil for the USA will peak in 1970. However, in December 2014, the United States once again leads the world in the production of oil, actually producing more oil than it did in 1970. Classify the fact that oil prices from August 2014 to December 2014 fell by over 50%. If Hubbard's theory of peak oil were correct, neither of these two facts would have taken place. Clearly, peak oil and the price of oil are trying to manipulate the demand for oil by creating a false sense of running out of oil. With a limited supply, demand and prices go up. Classify the fact that the supply has gone up. Prices have gone down, causing the best proof that peak oil as a theory is completely dead. Third, classify the fact that laws of thermodynamics prohibit spontaneous evolution of a liquid hydrocarbons in the regime of temperature and pressure characteristics of the crust of the Earth, one should not expect there to exist legitimate scientific evidence that might suggest that such could occur. Consequently, there exists no such evidence. Nonetheless, and surprisingly, there continues to be often promulgated diverse claims purporting to constitute evidence that natural petroleum somehow evolves miraculously from biological matter. Fourth, oil is often called a fossil fuel, that being it comes from former living organisms. This may have been possible back when oil wells were drilled into the fossil layers of the Earth's crust, but today, great quantities of oil are found in deeper wells that are found below the any level of any fossils. How could an oil come from fossils or decompose from living matter if it exists in rock formations far below layers of fossils as evidence of former living organisms? It must not come from living matter at all. 2 days after I read this statement, I encountered the following statement in a newspaper I deeply respect. Any geologist will tell you, well, most geologists will tell you, that oil is created by the magma of the Earth. The oil wells in Pennsylvania that were pumped out dry at the turn of the century and capped are now filled with oil again. Say what? This response from Daniel E. Reynolds on July 29, 1996, on the subject of oil, a renewable and abiotic fuel. Cross supply, the only reason we're still being taught that oil is a fossil fuel is to control the price of oil and to aid in the theory that we're running out of oil. Fifth, Academy of Sciences, Moscow. For almost a century, various predictions have been made that human race is imminently going to run out of available petroleum. The passing of time has proven all the predictions have been utterly wrong. Cross-supply how all predictions have depended fundamentally upon an archaic hypothesis from the 18th century that petroleum somehow miraculously evolved from biological detritus and is accordingly limited in abundance. That hypothesis has been replaced during the past 40 years by the modern Mercer-Cranian theory of deep abiotic petroleum origins, which has established that petroleum is a primordial material from great depth. Therefore, petroleum abundances are limited by little more than the quantities of its constituents as were incorporated into the earth at the time of its formation, and its availability depends upon technological development and exploration competence. Discovering commercial oil and gas rich in Kukra, Trinchina, Luvikia, and other areas. A total of 12 oil and gas fields recovered worth $4.38 billion and the price of 1991 and $26.3 billion in price 2008. For the discoveries of these new oil and gas accumulations, various scientists were awarded the State Prize of Ukraine in the field of science and technology in 1992. Today, there are 50 commercial gas and oil fields in fields known in the DB's northern flank. Data obtained from drilling in many of these areas show the crystalline base in the northern flank consists of amphibolites, draconite, diorites, genesis, granites, granodiorites, granitogenesis, migmatites, peridotitites, and schist. 32 of commercial fields have oil and gas accumulations in sandstone in the middle lower Carboniferous age. 16 other fields contain reservoirs in the same sandstone, but separately from them, and amphibolites, granites, and granodiorites of crystalline basement as well. 2 fields contain oil pools in crystalline basement only. 7th, a Russian book, Advanced Drilling Solutions detailing deep and ultra-deep drilling technology beyond the Earth's crust sedimentary layers to depths of over 40,000 feet. And it occurs in quantity in geologic domains where oil is relatively rare or absent, exhibited fold and thrust belts, and some large basins such as the West Siberian and San Juan basins, and in depths below 15,000 feet. Natural gas has been found at 21,000 feet in the granitic rocks of Sweden's Siljan meteoritic impact crater, and the deepest depths drilled in the earth in Oklahoma at 1,441 feet, and over 40,000 feet on the Kola Peninsula in Russia. A peculiar, there have been so little Western scientific peer reviews or acknowledgement of research verification concerning the ultra-deep Russian abiotic oil formation theory. Truly, this is suspicious and bears investigating, even if you don't believe the theory, because this will certainly remove the geopolitical effects and problems of the current thinking of oil that is running out. Concerning this theory, I've shown you why it is wrong. In the end, you have to agree that the Russian abiotic theory of oil formation, backed by all this evidence, is far more likely to be the true explanation. There appears to be little or no conclusive evidence to prove the Western biotic theory of oil, but that in and of itself leaves much unanswered, doesn't it? For what reasons then, a lot of these facts and conclusions is a peak oil theory based so heavily touted, a theory that is wholly dependent on a Western biotic theory of formation in which, as I see it, is completely unproven theory. Are Western geologists and scientists really that stupid or unfair, or is there an underlying hidden agenda and media steerage here by the big oil majors or OPEC to perhaps discreetly encourage higher oil prices to promote a false scarcity of this resource by conveniently deporting the Western biotic theory of oil formation, now disproven defunct, to so heavily promote Hubbard's peak oil theory? Follow the money. The only ones to gain from taunting this theory are the oil companies themselves. They pushed oil to record heights and held the developer with hostages to their whims. Then in summer 2014, a break in the stranglehold they once held OPEC on the exporting of oil. This is because of national greed and the fact the U.S. is now producing vast more sums of oil. Prices have dropped by more than 50% from June 2014 to December 2014. I'll leave you with this question and a prayer. Could oil actually lose 50% of its value if we're running out of it? And why is it that large oil companies have never really invested heavily into other forms of energy? It's because they know, like my partner and I do, they do not have to because they never will be running out of oil. We pray that you find for the petitioners in this case and vote for the promotion of the truth. Thank you for their time, and no further questions, I will retire. And that concludes our speeches for the pro-abiotic oil theory side. And if you have any questions for us, we'd be more than happy to answer them at this time and vice versa. Thank you so much for your applause. We really adored having this debate and listening to your wonderful speeches. Can you hear us all right?
Yes, it's clear.
Okay, so this, not the base concluded.
All right, one of my students have a question to ask.
Morning. I'm Ricky from UNFN. I would like to raise a question, which is, if oil is not a kind of fossil fuels, so why US is using biofuels to generate electricity?
Well, particularly that implication of the U.S. using biofuels for its energy is heavily stunted towards the big oil companies and OPEC. They can make the public believe that oil is being composed by fossil fuels. They control the price of oil and increase the prices for practically every person on Earth, because every person on Earth believes in just a scarcity. But even more so, we're looking at the Russian-Ukrainian theory, which we talked of in our speeches, that there actually is no proof that fossil fuels will be composing oil, and that it actually is a more plausible theory and workable theory in an abiotic sense, under non-biotic materials. Here in the US, however, it's been purported that fossil fuels are the way to go when believing in information and theories of oil. Because of that, because we have been given into any other aspects, and we've been so unilateral in our mindset, and again, it's because some oil companies rather keep us that way, we have a limited source of knowledge and limited sources of expanding our knowledge to anything besides a biofuel kind of world.
Thank you.
Oh.
Is there a question to ask?
Yes, we have a question for you. So my partner and I would like to know, when considering oil as a fossil fuel, which you argued for today, and that fossils haven't been found below 16,000 feet, yet oil has been found at depths of 40,000 feet or lower. How does the biotic theory of oil explain this? How then could oil be found at these depths if it's made by fossils?
As there is tectonic axes in the world, such as volcanic eruptions, so actually oil or kind of fossil fuels is stored at the stratas of the layers of rock. So
Kia Phong à mày không?
So fossil fuels such as oil is found way in the ground, usually between the layers of rock, just like what I said. And the repeated eruptions will lead to the high amount of fossil fuels in the stratus of the rock, so that oil could be found deep in the deep ground, under the ground. Yes.
Any more questions you'd like to ask?
We had one more question for you. My partner would like to ask it.
Is oil is it formed by the pressure?
Yes, so.
If so, is there more pressures in the center of the earth or in the crust?
We all think that there is different kinds of rock in the world, such as sedimentary rock. So sedimentary rock actually there are lots of stratas in sedimentary rock, and between the layers there are different kind of fossil fuels stored in the layers. So in the crust of the earth there are pressure. There are pressure so that sedimentary rock can be formed, and oil is compacted. The rock is compacted so that oil can be extracted from the crust. Yes. So we all think that it is formed by pressure by the crust of the earth. Yes.
I hope that satisfies you.
That was a lovely answer to that question. At this time, we have no more questions for
Okay,
you
I'm
two.
afraid we'll have to stop here because they have lessons in, actually the bell rang already.
Okay. Yes, we need to get going as well. Thank you so much for the debate
It was
today.
a pleasure talking to you, and we really enjoyed the debate.
Y'all have a wonderful day, and we'll talk to you next time.
You too, have a nice evening.
Thank you so much.